continue her lesson, having covered most of the northern warmer island of New Zealand, and we move on.
And they use this. So you have
Keep these visual images as best you can.
10% of the energy in New Zealand is geothermal, and a lot of people argue that this is a much cleaner energy than other kinds of energy. Using that energy that's flowing, the guys are using that
energy
to power things. Okay, so that's all the North Island of New Zealand. Now the South Island, permanent snowfields.
Remember, you're getting further from the equator, just the opposite of where we live in the Northern Hemisphere. So the further from the equator that you get going south, the colder it gets. Hence, this is the characteristics of the South Island.
It is further from the equator, so it's colder. And everybody, you were all in class today. I want you to get this right on the test. Put a big star by this. There will be a question. Which island is colder than the other? South Island is colder. And the reason why I make a point of it is because we tend to think North is colder for us in general. But when you're on the other side of the equator, it goes the other way.
So you remember that. There's a point.
Makes sense. It's common sense. And on a test, you want to make sure common sense is all kicking into gear. So here you're going to have alpine conifers, the kind of trees that we saw in northern Russia where things are cold. So this is, I'm leaving the South Island now with my airplane. And you've got this, but you can see then you hit these alpine areas with the conifers.
Like the Rockies.
Okay. And then just New Guinea.
Bear with me on this. Sorry for that mishap. We're back to New Guinea, which is just north of Australia. It's a major island, and she'll talk about it. Sorry.
And it's a little interesting because the eastern part is independent, so that's the part that is part of what we're talking about, and western is part of Indonesia, which will be another part of the world. Okay, Pacific Islands. For the Pacific Islands, you have two kinds of islands. You've got these high volcanic islands, and this is, there's sediment there at the base of this huge waterfall, but you would only have a huge waterfall because you have that height. And it's coming up out of the ocean from the volcano, and you're seeing the tip, but it's high, high.
Volcanic island.
And then you have another kind, which are atolls.
Atolls. Notice this.
And these are much lower, so you're not going to have any waterfalls. You're going to have low coconut palms, like the kind of things we see growing here. And how these are made is they depend on the volcanic island. So one is you have the volcanic island, and then you have something that comes secondary to that. So
volcanic, atolls, and she'll continue to explain.
The volcanic island starts, and then you've got your fringing reef with the shallow water where it can grow, and then your island starts to subside, and you are left with this living coral, this atoll, which then makes your area. And often inside you'll have a lagoon where you have this coral island. So after class, I'd love to hear what you have to say, but I'm going to move on because we have this. And these are low areas, so it's a huge issue. We talk about global climate change. Florida is obviously, this is a big deal. People are not buying certain kinds of property here because of it. And these are so low that they're actually, some of them are flooding out completely now. So this is happening today, and people live here, and this is a huge issue. So how?
Remember, these are coral islands, not unlike the coral that's actually underwater, coral reefs and so on. Keep that in mind. Atolls are coral islands.
How this works is you have your coral comes, and your mountain goes away, and it forms, and you lose your thing. It completely goes under, and you are just left with a coral atoll. There you go. Oh, and if you didn't see it again, that's sort of too bad. Okay? that works. Okay, climate, general climate.
Okay, we reviewed this earlier, but we'll review it again. And she will. This whole area in here particularly is that very, very arid area. Along the edges here, it's less arid, plus you have the underground water system that comes with the artesian wells.
Australia. We talked a lot about how the interior is dry. But also you have these tropical wet areas. The northern and eastern coasts are very wet, and you get a very different kind of vegetation and whatnot. And then you get these little Mediterranean bits, remember, as you're getting further from the equator.
Now, these are important because climate questions are obviously going to be on the test. The north and the east, as you see here, and they are closer to the equator. They're tropical, they're hot and they're wet, great for vegetation, agriculture, etc. Certain types of agriculture. Again, we talked about that being dry. And then you have the little Mediterranean areas that you have in the two corners here in the southern part of Australia. This is also where there's actually some great surfing. But my point is, these are more Mediterranean, which means they are warmed still by the position of Australia being closer to the equator. But down here, you're getting into the area that cools it. So it makes it more Mediterranean because of the coolness of the sea.
And in the Mediterranean, it's really good for growing what? Grapes. And when you go grapes, what's a good industry to have? Wine. Okay, so you have, this is a huge industry. Okay, wine is a big deal in, you've got Australian wine, you also have New Zealand wine, and you can go on wine tours there. It's like the wine country in California, but they have it there. So again, because of this climate, they can grow a certain thing, they develop a certain industry, it becomes part of their identity.
Wine is a major industry.
Okay, New Zealand climate, as a generality, on the western coasts are wet. And you have what is called orographic. Okay, New Zealand climate, as a generality, on the western coasts are wet. And you have what is called orographic rainfall.
Remember, orographic.
Orographic rainfall is when you have some kind of topography. So you have a mountain, and you have, I want a skinnier mountain. Okay, you've got this big fat mountain. It's going to work just fine. And then you have a cloud that's coming along, and then, oh. Clouds that are coming, and then they bump into the mountain. Whoo. So what they're going to do, what is easiest, it's easiest to just then rise up over the mountain. So then they start to go up. When you go up, it's going to be colder or hotter up here? Colder. So it's getting colder. Can the cloud hold more or less water? How much water? Less. So it has to drop its water. So it drops its water. Whoa, I can't hold it. So you get all this.
Very much like the Rockies, as the winds in our country all come primarily from the west, not just from the west, but from the west, and as they cross the continent and they hit the Rocky Mountains, as well as the Sierra Nevada Mountains in California, that forces the moisture in those clouds to compress, move up high, as she stated, and it turns into snowfall.
Rain. And it ends up super wet on this side. So the cloud keeps cruising.
The temperature.
And now it's starting to go down. It's getting warmer. Now it can hold more water, so it actually starts to suck up water. And so over here, you get what is called the rain shadow. Imagine if you guys had my handwriting all the time. So the rain shadow is the other side, the dry side. Okay, so orographic rainfall is where you have a topographic feature. It hits it, and it drops its rain, it goes to the other side, and then it sucks it up.
Notice all the livestock that was on that island in that graphic picture.
So